Awesome. So Kevin is a well-rounded ecologist with 40 years of field research and writing experience that he uses to solve complex environmental and ecological problems. He has expertise in subarctic and boreal ecology, landscape ecology, vegetation, botany, climate hydrology, wildlife disturbance, ecology, environmental contaminants, soil statistics, and the assessments of change over space and time. He has conducted research for federal and provincial governments, industry and non-governmental organizations, and First Nations. Clients have included BC Hydro, Alberta Pacific Forest Industries, Parks Canada, University of Alberta, Alberta Government, the International Crane Foundation, Government of the Northwest Territories, Many Health Board Society, Fort Chipewyan, Keepers of the Athabasca, Keepers of the Water, Dene, the First Nation, Athabasca Chipewyan First Nation, Fort McKay First Nation, the Athabasca Tribal Council, the Little Red River, Cree Nation, Global Forest Watch Canada, Sierra Club, Environmental Defense Canada, and the Pembina Institute, Wildlife, World Wildlife Fund, Canadian Parks and Wilderness Society, Alberta Wilderness Association, Rocky Mountain Ecosystem Coalition, the Forest Stewardship Council, Friends of the Chinchaga, and the Castle Crown Wilderness Coalition. He is an avid woodsman, naturalist, musician, gardener, and backcountry traveler. His book, The Peace, Athabasca Delta, Portrait of a Dynamic Ecosystem, 2013 University of Alberta Press, received numerous awards, including the Lane Anderson Award for Best Science Book Published in Canada. His book, Impaired Wetlands in a Damaged Landscape, The Legacy of Bitumen Exploitation in Canada, documenting wholesale permanent landscape degradation resulting from bitumen exploitation in Alberta. His most recent book, Hidden Scourge, Exposing the Truth about Fossil Fuel Industry Spills, was published in October 2021. So without further ado, Kevin.
Okay, thank you. Now, I just want to get this screen up. Can everyone see the full screen here?
Yeah, we can see it now.
Excellent. Okay, so how do I get rid of this here? This screen sharing, is that going to disappear? Can I maximize the screen? Sorry about just a little technical thing here.
You can move it.
You
You can move it out of your way, but I don't know if you can get rid of it.
Okay, more over here.
Sorry, we had to switch.
Sorry, we just switched computers here. The computer crashed the last minute. Well,
it's pretty clear from where we can see. From all
okay,
yeah.
So can we just move this off to the side so I'm not distracted?
Oh, God.
Okay. All right. Can everyone see the slide? Still?
Yes. Yeah.
Okay, excellent. All right. Thank you for that wonderful introduction. I'd like to talk to you today about the book Hidden Scourge, that the subtitle, Exposing the Truth about Fossil Fuel Industry Spills, and some of the lessons that I learned while I was doing that work. The first thing I'd like to tell you about is that one of the most important skills that you can learn when you're dealing with the regulatory information and industry information is to learn to see through smoke. And I hope to be able to impart some of those features or some of those practices today. So the presentation is divided into 8 parts. How the parts fit together will be first, then I'll cover some important concepts, talk about the focus of the study, some of the findings, and then I'll provide a geographic or map overview of the spills for 5 jurisdictions, look at some of the conditions at the well sites. Then I'll talk about a concept called the disturbance signature, cumulative effects, and finally end up with the talk about regulatory capture and the meta-organization. So the presentation is sort of based on 5 different sources, this presentation. So Hidden Scourge lies at the center, and then available to everyone free online are the other 5 files that surround Hidden Scourge, and you can access those files from the web link at the bottom of the page. Essentially, what those 5 files do is to provide you with all the detailed evidence all the data, the discussions, the statistics, the tables, figures, etc., that wouldn't fit in a in a normal book for the public. So it started out 6 years ago as I tried to follow some breadcrumbs, and the first breadcrumb that I found was that perfect spill recovery that I was looking at. I was finding thousands of spills where the regulator was reporting that the industry had perfect recovery of the spill. So I thought, well, that can't be true in the real world. But what else is false or inaccurate about regulatory data? So that led me on a long several year analysis where I documented thousands of missing spills, missing data, inaccurate and fabricated spill and recovery volumes, and inaccurate spill locations. I found a failure to assess environmental impacts, failure to assess habitat damage and animal deaths, misinformation and disinformation on sensitive areas, spill footprints, remediation, reclamation, and the causes of spills. That then led me to compare the regulatory information with the science, and I found that contamination and ecological effects were both pervasive and persistent. That led me to expand to other jurisdictions, and what I found was that there was also permanent damage and poor regulatory data wherever I looked. And so I then had to expand the scope to look at the regulatory capture, and I found that the impacts on the land and the data corruption were the result of regulatory capture, and that the captured regulators were interestingly performing exactly as they were designed to do, and that is to facilitate the exploitation. And finally, I had to conclude that regulatory capture is nested within an undermining of our democratic institutions. So first, some important concepts. Regulatory capture is a state in which the decisions, actions, or resources of a regulator are directed away from the public interest in favor of a private interest through the actions of that interest. And it's a form of quasi-legal corruption. Second concept is the self-concept of the Alberta Energy Regulator. So I'm quoting them. The AER ensures the safe, efficient, orderly, and environmentally responsible development of energy resources. We make sure energy development doesn't damage any aspect of our province's environment. The AER sees itself as a credible and transparent organization that demonstrates empathic engagement, stellar competence, and regulatory excellence. Several other important concepts here. The first one is that a vegetated or green area is not necessarily healthy. You can see here in the upper right, I show you sort of the right and left panels. The green area is actually a foxtail barley overgrazed weedy meadow with 95% exotic species, and the soil and the groundwater are fecal and nitrogen contaminated. On the left is a native moist savanna with very high biodiversity and a healthy soil and predominantly native species. So the fact that something is green or is growing plants does not mean that it is healthy. In fact, it often means the opposite. Then another concept is a domain. The domain is a range of natural variability in the biological, physical, and chemical components and processes of an ecosystem. A domain shift occurs when an ecosystem is pushed outside the boundaries of its former domain. Bootstrapping is the capacity of an ecosystem to reconstitute itself after a disturbance. A disturbance signature is a distinct or persistent change in attributes. You can think of it as a fingerprint. And a shifted baseline is the loss of reference or natural control conditions. All of these things are important to realize as we go through the data. So a quick look here at ecological domains, little sort of ball and cup model here. We can think of an ecosystem as varying from year to year and season to season, but it's always returning to sort of its mean position that is at the bottom of this depression here. And it's recognizable from year to year as we'll say an old growth white spruce, paper birch, balsam fir forest, as you see pictured on the left. If you push that system too hard by removing all the vegetation and damaging the soil, you can push it into an entirely different domain that you've pushed it past a threshold or a tipping point, and it will not return to the original domain, even if you wait an indefinite period. That's due to the loss of bootstrapping capacity, and primarily that's due to the loss of all the symbiotic relationships in the soil. Oops, I'm pressing the wrong keyboard here. Another concept that's important to realize is shifted baselines. It's very difficult for us to determine in the present how much change we're observing in our world if we don't have data that go back in time. So if we want to determine, say, what's the total biodiversity on our landscape, or how many caribou we have, or grizzly bears, or the proportion of healthy wetlands, and we only have the present, we're really blinded to what is happening. So if we can go back 20 years, we may find a slight amount of change. If we can go back 40 or even 60 years, we'll find that we may be able to have a much better idea of the change. The problem is that very often we lose that original baseline data because the landscape has been so utterly transformed. And in particular for the hydrocarbon industry, if we can't go back prior to 1960, we're already seeing a profoundly changed landscape. So I use the analogy here of the night sky. We may look up at the night sky now and say, well, that's a starry night and everything is fine. But if we had a perspective on the past and we can look back to how it was, say, some years ago, we'd say, now that's what we had, and we've lost so many things now. It's sort of, the stars are sort of species and plant communities and wildlife populations. And so if we don't have that ability to go back in time, we're not going to be sensitive to those changes. Here's an example from the Swan River area in the Swan Hills, 30 years of breeding bird survey data. And we see it's a significant decline, not only in the number of bird species, but in the overall abundance of breeding birds. And that decline in abundance is called defaunation, that is the depopulation of the landscape. But even though this is a significant decline, the declines are underestimated due to our shifted baseline. We only have data that go back to 1987, long after the industry was quite active in that area. Okay, now switching to the study focus here, where we're looking at the hidden scourge, looked primarily at upstream production spills. I had data from 5 regulators, Alberta, Saskatchewan, North Dakota, Montana, and also the National Energy Board, which gave me data on over 103,000 spills. I also had field plot data from 4 regions, 454 field plots. And then later I added quite a few plots as I was in the later stage of writing the book. I've also referred extensively to the scientific and the gray literature or the industrial reports, conducted a lot of correspondence and interviews, relied on some really good investigative journalists who do great work. And I also submitted a FOIP to the Alberta Energy Regulator. And those of you who have submitted FOIPs will know, will empathize with this Gary Larson cartoon in the lower left here, where the public and the AER are sitting at a counselor, and the public is trying to tell the counselor, listen, I've tried to communicate with him, but he's like a broken record. None of your beeswax, none of your beeswax. This is what it's like to FOIP the AER. So the spill categories that were the main focus of the study here are the conventional, and by conventional, I mean conventional oil and gas rather than things like bitumen, conventional oil and gas from 1975 onward. But there are many other categories of spills, such as missing spills after that date, conventional upstream spills prior to 1975, and then there's unconventional spills from bitumen and other unconventional hydrocarbons. spills from refineries and tank farms, product distribution pipelines, trucks and railway cars, interprovincial pipelines, and finally users. Users are, of course, a huge category of spills. And a good example right now is the leakage from the fuel tank in Iqaluit that has contaminated their drinking water. So I'm just trying to get the point across here that there are many different kinds of spills, but we're mainly going to be talking about what are called the upstream spills that are caused while the companies are extracting the hydrocarbons from the ground. I tried to get an idea, since the record only starts in 1975, about the number of missing spills prior to 1975. And so I just did a sort of a backcasting to the time of zero wells. And I came up with an estimate of 5,000 missing spills prior to 1975 in Alberta. But that number is a gross underestimate of the reality for many reasons that we'll get into later on. But one of which is that the practices in the early days were far more polluting than they were in later decades. So you can see here a standard practice back in 1940s was to dig large holes and then dump the crude oil in these pits. These were unlined pits until someone could come by in a vacuum truck, suck the crude oil out of the ground, and then after they were done with that pit, they would simply bulldoze it. So this would classify as a major contaminant event, but none of these, of course, are part of the spill record either. Now, some of the findings, or as I would like, as I came to understand it, a tour of hell's library. So the first graph I'd like to show you here is that of the total number of saline and crude oil spills in Alberta, as reported by the Alberta Energy Regulator. That's the blue line here. So you see a rising number of spills through the 1970s to the mid-90s, and then a decline since then. If we look at the overall annual production of conventional oil in the province, we see a sort of long-term multi-decadal decline. Now, one thing that is really quite interesting about this graph here is that the number of spills that we're finding in early years are inversely or negatively correlated with the annual oil production. That's a red flag right there. That's not the sort of thing you would find in the real world. What you would find is something similar to from 1997 onward, where the overall number of spills is clearly correlated, positively correlated with the annual oil production. So what that tells you is that from 1975 up through late 1990s, they're just simply missing spills. So they're missing many thousands of spills that were just simply not reported to the Alberta Energy Regulator. And we'll get to that topic a little bit more. Pre-1975 spills, of course, are another large problem. And here's an eyewitness testimony from someone who worked in the oil patch. He wrote to me recently and he said, "My exposure to this began, like many of Alberta's farm boys, with employment in the oil patch. We were regularly dispatched to an oil field centered around Didsbury. Maintenance was chronically underfunded, even in those days, and oil storage tanks leaked like sieves. We would pull into a site to find the dike surrounding the tanks brimming with oil from leaks. A backhoe would breach the dike, oil would pour out onto the surrounding land, and then we would shovel gravel on top of the spill to disguise it. To my knowledge, these leaks and spills were never reported. No one in authority ever came to inspect them, and the situation would be repeated." I could give you many other examples from all across Canada, from BC all the way to Nova Scotia, but suffice to say, it is a common problem all across Canada, and indeed wherever hydrocarbons are produced. Another major finding here was that the total number of spills and the total volume of spills that have been recorded and reported by the Alberta Energy Regulator are a gross underestimate of the total number of spills and the total volume. I'll give you two very good examples here. The two largest spills in Canadian history, that is the Atlantic number 3 1948 crude oil well blowout near Leduc, is the largest spill in Canadian history of crude oil, and the Peace River Oil's number 1 well along the Peace River, spewed a tremendous volume, a staggering volume of saline water, primarily right into the Peace River for 87 years. The total volume of that single spill is over 100 times the volume of the total AER database of recorded saline spill volumes. Similarly, for the crude oil from that single event that was not even part of the Alberta Energy Regulator's record, from that single event, the total crude oil release almost equals the total of 30,329 crude oil spills that are officially reported. So what we can conclude from that is that what we have to work with in terms of what's reported by the regulator is a small fraction of what's actually happened on the landscape. Another interesting technique I used here was to look at oil spills on satellite imagery. And we can see here that this is a spill from 2002 in southwestern Alberta. The satellite image taken 6 days after the spill shows where, according to the Alberta Energy Regulator, only 0.6 cubic meters of crude oil were spilled. Notice they've also provided an inaccurate spill location. It's off by 147 meters. Most importantly, I tallied up the area of the footprint. You'll see it's 1,563 square meters. There's no way no physical way for 0.6 cubic meters of crude oil to spread over an area that size sufficiently to darken the soil and be visible on a low resolution old satellite image. So here it's another example of underreporting of the actual volume spilled. AER spill locations are often inaccurate, sometimes wildly so. This is an example from the Barnwell spill I studied in northwestern Alberta. The actual location was off by 500 meters. Now, a situation like that, if you do not have local knowledge holders to take you to that spill site, you are never going to find it, because you're basically trying to find a needle in a haystack. Fortunately, I had Denetah people to take me to the site. Another factor, another attribute of spills is what are called spill footprints, and that is the area of the ground that's covered by a spill. The Alberta data are worthless. They can't be used at all, but the Saskatchewan data are fairly good. And what I did with those is that you can see the graph here on the top of saline water spill volume in relation to the reported area impacted. And I did the same thing for the thousands of crude oil spills reported from Saskatchewan. And what I found was, well, interesting thing in ecology, we call these plots dust bunny plots because they look like a dust bunny in a corner. You only find that a dust bunny relationship when there's a weak relationship between two variables. So what we see here is that for a given spill volume of, say, 1 cubic meter, the footprints ranged over 10,000 fold. And similarly, for a given footprint, the spill volumes also ranged over 10,000 fold. So that's not a possible relationship in nature. You can have, for example, 1 cubic meter of crude oil produce a footprint that ranges from a square meter to over 10,000 square meters. So this tells us that the footprint data and or the volume data that are reported from Saskatchewan are not credible. I also looked at the, in this case for crude oil spills, I graphed the recovery efficiency, that is the amount of oil reported as recovered versus the amount of oil recovered as spilled, versus the volume of the oil spill. And what I found were these beautifully symmetrical plots that looked to my eye like a peregrine falcon stooping onto its prey. So I just, for short, I call these falcon effects. It took me a long time, well over a month, probably 2 months, to figure out what was going on here. And essentially the result was both shocking and simple. The simple answer is that these plots are created by this subjective choice of numeric values. So when you see these plots, you know that the values that are being reported as spilled and recovered on the landscape are not actual measurements. These are numbers that have been chosen by people in the field. And so they will choose things like, oh, we got all 100% of the spill, or we got a half, or we got 3/4 or whatever. So they're not actually making any measurements. They're just they're fabricating the data. So that is a very important finding in that it's hard proof that the values that are being reported by the regulators are not real or not actual measurements. They're numbers that people have made up. And the people who are making up the numbers are those who are doing the spilling. Another way I looked at the regulators' data, I did this for all the regulators, was to do a statistical analysis known as Benford analysis. I'm not going to get into that, I promise, but all I'm trying to say here is that this analysis allows me to determine whether a set of numeric values have been chosen by humans or whether they've been measured. And then we can calculate the deviation from the expectation of random expectation. And what we find is that the most subjectively chosen values are Alberta crude oil efficiency. In other words, they're the most subjective, they're the most made up. And you can see here, the R and the Q and the P, those are all other Alberta reported data. In other words, what we're finding from all the regulators, but in particular from the Alberta regulators, is that the numbers that are being reported are made up, and people are making these values up because there's a pressure to report good news. They, after all, are the ones who are responsible for the spill, so they'll tend to underestimate the spill volume, overestimate the spill recovery, and minimize or not even report ecological impact. So if you are the bearer of the news, why be the bearer of bad news if the regulator is not checking? And this has gone on for decades. Three other areas that I looked at in some excruciating detail, but I'll just quickly touch on them. As I looked at what are called sensitive areas. So sensitive areas are ecologically sensitive areas. And according to the Alberta, what I used was Alberta Environment and Parks, good GIS data of sensitive areas in Alberta. And then I plotted the distribution of the spills across those sensitive areas. And I found that the Alberta Energy Regulator is under-reporting the occurrence of sensitive areas by a factor of 200 times. In other words, the AER is grossly understating the ecological sensitivity of the landscape. When I brought this to their attention, they doubled down and they changed their data entry rules such that the only quote unquote valid entry for a sensitive area is no. In other words, if someone says it's a sensitive area and they write yes when they're reporting it, that will be an invalid entry. So basically by fiat, they've said sensitive areas no longer exist. Spill harm rates in Alberta, what I did with that is I compared industry reported environmental harm rates from Oklahoma with those in Alberta, and I standardized based on the kinds of spills and the spill volumes. And I found that in Oklahoma, the industry is reporting that they've done harm 39 to 40 times more often than industry reports harm in Alberta. So in other words, the AER is grossly understating the rates of harm by the industry. Finally, I looked at causes of spills. And to make a very long story short, this took me more than a month to work through. What I found was that, shockingly, it's an ad hoc collection of vague and overlapping and illogical categories without quality control. So when you try to analyze the data to come up with an important finding, such as what is the cause of these spills, what are the main causes, what you'll come up with is random noise. So those data from Alberta are most useful as evidence of a dysfunctional regulatory culture. Finally, another interesting example of how false that the regulators reporting can be. And on the left-hand side here, you see a 2014 spill, a large contaminated surface water spill of more than 3,000 cubic meters from a Pembina NGL Corp sour gas fractionation plant. The AER said the area was not sensitive, the cause was natural phenomena, and the failure type was a water retention pond. Now, I know this is false because this is Half Moon Lake, which is like 300 meters from our house here. And so what I found was, though, first of all, there's no sour gas plant there. There's no company operating at that location. It's a natural lake. It's a sensitive area, most definitely. And so digging a little further, I found out that the AER had reported or misreported the location by 50 kilometers. The actual location took place at the Pembina plant in Redwater, which is directly due north of here. So it's on the same range road, but it's just 50 kilometers off. And they report this information to us, the public, without any data checking for errors. Another glaring error was this spill from Fort Chipewyan in 2016. The AER reported that there was a malfunction of production equipment and as the cause of the spill, but there's no hydrocarbons produced in Fort Chip and there's no hydrocarbon production equipment. There was no spill that occurred here. So essentially what you find is, as you go over the Alberta Energy Regulator's data, that there are errors everywhere in all the attributes. So this is why I called it Hell's Library. I had to ask myself, how can such wildly inaccurate information be produced, not be corrected for years, and be distributed to the public? And the answer to that is regulatory capture. Now I'd like to switch topics and give you a geographic overview of the spills and then well sites and the on-the-ground conditions of the well sites. We start in the northern third of Alberta. We see the overall pattern of spills, and then we can zoom in the lower left here to show you the pattern of spills around the Hay-Zama Lakes and Zama City in the territory of the Denetah First Nation. Spills in the central third of Alberta and near the town of Swan Hills. You can see the cumulative effects from not only the hydrocarbon industry, but also from the logging industry. Spills spread across the southern third of Alberta and zooming in a little closer to the area north of Wainwright in southeastern Alberta. Moving over to Saskatchewan, we see here the spills distributed across the southern half of Saskatchewan and in somewhat more detail in southeastern Saskatchewan near the town of Oxbow. Moving down to North Dakota, we can see a strong cluster of spills, primarily in the northwest of the state. And if we zoom in along the Missouri River, we see a really dense accumulation of spills. As we move over to Montana, we see the spills are more or less concentrated along the eastern boundary with North Dakota, and we can see a little more detail in the lower panel here at the Montana-North Dakota border. Interprovincial pipeline spills, that's National Energy Board or Canadian Energy Regulator spills. In the top here, you see the pattern of spills from BC to northwestern Ontario, and then in the bottom from northwestern Ontario across to Nova Scotia. Now switching to wells, I'm plotting here and available to you free from the website is the full database of the location and type of basically 490,000 fossil fuel industry wells in Alberta. So we'll just have a quick survey of their distribution. That's the northern third of Alberta, the central third of Alberta, and the southern third of Alberta. Now, if we look at just the type of wells we call abandoned wells, there are over 79,000 such wells in Alberta, and they're distributed pretty well all across the province. And the only area where there's not sort of wall-to-wall abandoned wells is in the northern tier of the province, especially in the area of Wood Buffalo, and then in the mountain parks. Now, if we look at some of the conditions at the well sites, We see here in the upper left the pattern of abandoned wells near Dinosaur Provincial Park in the South Saskatchewan River. The X in the upper panel shows the location of the two abandoned wells I show you in the lower right. You can see, so these sites are essentially bare ground, heavily disturbed, very much unlike any of the natural surrounding vegetation. What are the conditions like at reclamation certified wells? So reclamation certified simply means that the certification has been by the regulator. They've not been certified by an ecologist or someone who would have particular expertise in soil or land health. These reclamation certified wells have been in the fully recovered state, according to the regulator, for 21 to 22 years. And you can see that in all cases, the areas at the red dots are completely unlike the surrounding landscape. So, even though you'll hear, oh, this is reclamation certified, what you're actually hearing is that it's certified to the acceptance of the regulator, but ecologically, it's a mess. Another word you hear a lot of is remediation. Remediation is not restoration to natural or healthy conditions. Remediation simply means that an attempt that was acceptable to the regulator has been made to clean up an industrial site. So I illustrate here 5 years after the completion, quote unquote, of remediation at the Apache 15 of 9 spill in the land of the Dene Ta. We see here a prominent salt crust remaining on the soil. The soil is quite contaminated now, and you can see the white spruce trees that have been planted as part of the remediation are dying as a result of the salt contamination. Okay, I'd like to move on now to what I call the disturbance signature. And why is that important? Well, it conveys information to you once you learn to read the signs. It provides the proof of harm, and it also provides a warning of danger. For example, the city of Calgary has found that there are more than 1,766 contaminated sites within Calgary. When they tried to get the information about those sites, they were shocked to find that there were very poor records, or in some cases, no records. So the ability to recognize that something is different allows you to zero in, to pinpoint and say, yes, something happened here. We need to understand what has happened. We also, the signature is important also because it dispels misconceptions that, for example, the Alberta Energy Regulator is protecting the environment, or that hydrocarbon exploitation is ecologically sustainable, and it is not, as you can see. So this Gary Larson cartoon here, what I'm trying to do here is, inject a little humor into a sad story here, but the hunter is telling his son that after a while you'll develop an eye for these things yourself. He's out trying to tell the son where the deer has been. So what I'm going to try to do here is to give you some tips as to how to identify disturbance signatures. So first of all, you need to know that the disturbance signature is a function of the pre-disturbance conditions, and then the type, the number, the intensity, and the extent of the disturbances, and then the time since disturbance. So if I were to disturb an area on the right-hand panel here, I don't have the correct computer here, so I can't move my mouse around. Okay, there we go, good. So if this area were disturbed, or this area were disturbed, or this riparian meadow were disturbed, or this mixedwood forest were disturbed, it's going to affect somewhat what we actually find after the disturbance. So disturbance signatures vary. You can see here in northwestern Alberta in what's called the Amber Battery, again in the land of the Dene Ta. The area has been both salt and oil contaminated, heavily impacted site dominated by foxtail barley and alsike clover. And in the lower right, we see more than 70 years after a crude oil spill in the alpine tundra along the Canal Road, a very different community than we find in the alpine tundra adjacent to the spill. So each species, each attribute can give you a message. It's telling you something about what has happened. One of the dangers we face is that quite often the contaminants are hidden underground. They're hard to see, and they sometimes require laboratory analyses. But the beauty of the disturbance signature is that the damage is detectable on the surface because we see evidence of a change, a radical change in the landscape cover. So in the upper left here, we see multiple saline spills near the Apache sour gas plant in northwestern Alberta. We can tell that by the pure population of the foxtail barley here. In the upper right, we see a heavily contaminated site in Texas where they removed 107,000 cubic yards of contaminated soil, highly contaminated and dangerous conditions there. In the lower left, we see an area that looks healthy, but it's actually a contaminated marsh that's been created as a result of remediation attempts in a bog fen after the Pace spyglass oil spill. And finally, in the lower right, we see permanently damaged soil more than 70 years after the crude oil blowout at the Atlantic number 3 site, the largest crude oil spill in Canadian history. That area has developed what are called impermeable soils or water repellent soils as a result of some of the chemical changes there. So you can actually see these bare soil patches from the air. So now I'm not going to get into this. Don't be too alarmed when you see these tables. What I'm just simply trying to demonstrate here is that within a 5-minute presentation of this material, that there are many different species indicators that will differ from habitat and from regions wherever you're working. And you can use these indicators to tell you that, yes, the disturbance has taken place here. One of the primary things you're going to see on these spills and industrial sites in general is an increase in exotic grasses. So exotic means non-native. But you'll also find many sort of exotic plants like scentless chamomile and pineapple weed and various sow thistles. So again, it's something, it takes a bit of a learning curve to climb, but once you learn how to recognize various species, you'll be able to walk around the landscape and say, yes, a spill has happened here. There are other indicators such as an increase in pollution tolerant and salt tolerant species. Virtual absence of lichens. Lichens are extremely susceptible to disturbance, so they basically disappear. You'll find an increase in blue-green algae growing on the soil and in the water. And in vegetation landscape indicators, you'll find, for example, major decreases in the proportion of peatlands and increases in weedy meadows as a result of the spills. You'll also find things like decreased vegetation type diversity. The plants tend to be smaller to cover less of the ground, to be shorter, etc. So there are many, many ways to tell that a spill has taken place on the landscape. Physical indicators include, most obviously to the naked eye as you reach a site, an increase in the proportion of bare ground, and things like when you're on permafrost soils, an increase in the depth of the active layer. You may find in soils, you'll find a large suite of chemicals that are raised above backgrounds. Obviously, things like sodium and chloride, PAHs, petroleum hydrocarbons. In some cases, there will be residual tar or oil or salt crusts evident on the soil surface, and they can persist many years after the spills. You'll find things like in water, another set of indicators that tell you that the land has been or the water has been subjected to a spill. And in the case of areas where you're looking at groundwater, you may find that there's a decrease in the pH if acidic fracking water is leaking into the groundwater. Now, there's another way to look at this, and that's to flip it upside down and say, what are the contraindicators? What are the plants that if you see them, you know that a disturbance hasn't taken place? That's the sort of most native plants, because most native plants don't tolerate spills and disturbances very well. So if you see an abundance of woody plants, mosses, and lichens on a site, and they're all native species, you can be quite sure that the area has not been subjected to a spill. Now, when I look at all these data from the plots, again, this is far more detailed than we need, but I just want to show you that there is a clear break in the composition of the plots. In the upper left, we see natural controls in green versus the other colors so the position of these symbols in space is in relation to the species composition within the plot. And we see here there's a clear break between the spill sites and the natural controls. Same thing for the in the bottom left in north central and northeastern Alberta, a clear break in composition between the disturbed and natural conditions. The upper right shows a similar situation in alpine sedge tundra after oil spills along the Canal Road. And in the bottom right, I show you a soil ordination where I looked at the plots from the Rumsey Moraine. These are well sites here. And what you're seeing is that even though they're well sites without a recorded spill, they're actually recording changes to their soils that are very, very similar to what you would find after a spill. So either there were spills at these well sites that were not recorded, or the overall abuse of the site leads to similar changes. So what do the disturbance signatures look like in the real world? We see here in the upper left, foxtail barley is a very good indicator. Also scentless chamomile. I don't know if you can see it here, but there's scentless chamomile, a restricted exotic weed here. Proportion of bare ground, of course, rises a lot. This is near the Apache sour gas plant in the northwest. This area here, I discovered sort of serendipitously. This is right in Sherwood Park in the middle of a subdivision. It's a 40-year spill, a crude oil spill. And so the plants that are growing at the center of the spill still have a very clear disturbance signature. For example, you'll find things like cattail and reed canary grass that are both very tolerant of that disturbance. And another interesting fact about this was that the people who now own this property here adjacent to the spill had no idea that a spill had even taken place. Moving down to this next panel, we see here some halophytes that have moved into another Apache spill site as a result of the salt contamination. In the center, this is the paste spyglass oil spill. A really interesting, unique community has formed in the aftermath of the oil spill that's now dominated by blue-green algae. That's the funny blue color in the water there. This is another Apache site where they've excavated to try to remove the contaminants. You can see here it's essentially devoid of any vegetation and animal life. It's because they're contaminated with salt. So in the lower left, this is a satellite view more than 70 years after the Atlantic #3 disaster. And you can see where I put B, those are bare soil patches. And then S is stress vegetation. We visited these sites on the ground. And finally, in the lower panel, you see 35, 55, and 70 years after a crude oil spill in the Canal Road, in a predominance of bare ground. A little more spill signatures. So again, from the upper left, we see a lot of barren ground, and halophytes are the only things that can grow beyond the bare ground. Similarly here at a battery site in Bruderheim, according to the regulator, there's virtually no spill here, but the soil is heavily contaminated. This is a site here in the upper right in near Chipewyan Lake, which is not near Fort Chipewyan. This is a totally different area east of Fort McMurray. This area has been for decades basically looking extremely impoverished. This is where they've dumped drilling waste. So this is another kind of damage that were not even part of the study, but I just happened to discover it while I was doing other work. Along the right-hand panel here, you see the soil at the Atlantic #3 site near Leduc. and in the lower right, the same site. So these sites have developed, they were basically, for those of you who know soils, they started out as a beautiful black Chernozem, and now they are essentially bombed back to the Stone Age, as they say, and they're Regisol. So they're new, they're sort of like new geologic material that is extremely water repellent. The water just sits on top. It doesn't percolate. So they become basically deserts. In the lower center here, you see a well site that has been certified reclaimed. In the lower left, you see a pipeline right of way. Both of those situations, the vegetation is a complete admixture of planted and exotic species without any real convergence over the decades in its composition towards the original natural conditions. And finally, in the center left here, we see a saline spill in North Dakota that's 50 years after the spill. One final point here about the landscape disturbance signature is that sometimes people confuse salinized landscapes with saline landscapes. And I say they're as similar as lightning and lightning bugs. So in the lower right here, you see a beautiful biodiverse saline landscape up in Wood Buffalo National Park. Really wonderful communities in here, interesting diatom communities, high quality nesting area for rare whooping cranes. And we compare that to a salinized landscape here at a well site near Bruderheim in Strathcona County, where there was, according to the regulator, a single spill of 30 years ago where they had perfect spill recovery. But you can see here that the soil is essentially permanently contaminated with salt. So salinized and saline landscapes are very different. Moving on now to cumulative effects. We often hear about cumulative effects and how we can understand them, but I'm here to tell you that most cumulative effects are more complex than we can model. This is a simplified model that I drew up for the Peace Athabasca Delta some years ago. Now, if we were to try to expand this to the entire oil patch and try to predict all the, to integrate all of the stresses on the landscape and predict what's going to happen, we would quickly find that the model was far beyond our a working size, and we would not be able to predict the future. One of the problems with the trying to assess cumulative effects is that it's difficult to actually come up with an actual meaningful footprint. In Alberta, there are more than 30,000 square kilometers of the actual footprint, but the actual effects of the industry extend well beyond the footprint in the form of oil pollution, of soil pollution and air pollution, light pollution, noise pollution, the way in which they are changing how water moves across the landscape, how animals move across the landscape. So the effects are far greater than the footprint size. Now, focusing on seismic lines for a second here, we know that there are at least 2 million kilometers of satellite detectable seismic lines in Alberta, but that's really, again, it's an underestimate because in more recent years, these high density seismic lines have become difficult for satellite imagery to detect. So you see here the actual pattern of high density seismic lines in the top panel and what the Alberta Biodiversity Monitoring Institute managed to capture from satellite imagery. So they're basically finding less than 1/2 of the actual number of seismic lines on the landscape, which is a large error. And it's also quite shocking that some years ago, it was decided that the old records for the seismic lines would be discarded, all the paper files and whatnot. And so for those of us who are trying to understand and document seismic lines on the landscape, it becomes even more difficult because the records have been erased. We can tally the effects of cumulative actions on the landscapes. We're pretty good at that. So again, I'm not going to get into this, but just to say that the scientific literature is quite robust, documenting the effects of the industry and in humans in general at the ecosystem level, and effects at the population and community level, including declines in fisheries, changes in animal populations, increased in poaching, decreased native biodiversity, etc. And then we can move to the social and political effects. And some of those are the separation of politically powerful areas of consumption from impoverished areas of production. So we have haves and have-nots. The people who are getting all of the benefit are not in the area where most of the damage is occurring, and those people are, they're living in in rural areas. They're getting very little of the benefits and all of the impacts, and that's of course not fair. It's just morally wrong. There's also, of course, loss of traditional use and treaty rights and regulatory capture. We've noticed already the privatization of profits, while we have increased financial liabilities for society. And at the largest level, the erosion of our very democratic institutions and loss of trust in government. What do cumulative effects look on the landscape? Very quickly here, we see what an area northeast of Lodgepole, where I plotted not only the spills that are reported, but also I've colored the intensity of the red is proportional to the number of spills. So the arrow that's pointing to, the red arrow is pointing to a site where 11 spills have been reported. The yellow points to an area where 8 spills have been reported. So in an area such as this, where you have all of these spills, all of this dense infrastructure of wells and pipelines, there are going to be many cumulative effects, which will of course include things like habitat loss and fragmentation, impacts to air quality, water quality, the health of the land, wildlife impacts, and of course the quality of life. And when you're in an area that's subjected to these intense disturbances, as a human, you can suffer health effects just from the stress of having to deal with that on a day-to-day basis. On the right-hand panel, we see an area in northwestern Alberta. So the pond is a created pond that was created in an attempt to excavate the salt-contaminated terrain, the peat. According to the regulator, this was a very good thing because they created wildlife habitat when they've actually created a mortality sink of contaminated water for wildlife to be endangered in. The area surrounding the pond is also still salt contaminated, and it's basically covered by a weedy, exotic, salt tolerant vegetation. So essentially what we can say is that landscapes exploited for hydrocarbons have been permanently changed, and then cumulative effects that come from agriculture and the overall settlement process of building all the roads and logging industry are all working together to stress the landscape far more than only one industry can. In the lower left, I just wanted to point out to you the area of town of Peace River. There's over 1,000 spills in that area plotted in red. We also see a dense road network, and then of course the loss of the Peace River Prairie native grassland turned under for agriculture. Finally, in the lower right, a really unsustainable use that is still allowed, that is the wholesale drainage of our boreal peatlands to create agricultural fields to basically grow hay, extremely unsustainable and a massive loss of carbon to the atmosphere. And finally, an emerging threat is the use of fracking wastewater injection wells. Scientists recently plotted the distribution of those wells here. You can see in the lower right panel. And the ecological effects and social effects of that practice really need to be addressed. Climate change is, of course, a major stress multiplier. I show you here a graph, not a graph, a satellite image that shows 19 years of recent forest fires spread across from northwest of Great Slave Lake down to Hudson Bay. All of the colored polygons are areas that have burned in only a 19-year period. This is not normal to burn that proportion of the landscape in so short a time. So clearly, you know, all of the effects that we are causing on the landscape are, of course, being worsened by an increase in the wildfire activity. In Alberta, we also have another problem about human-caused wildfires. In Alberta, humans cause more wildfires and more burned area than any other jurisdiction in Canada. Two of the biggest examples are the 2011 Richardson River Fire and the 2016 Richardson Fort McMurray Fire, nicknamed the Beast. The 2016 fire caused $9.9 billion worth of damage and untold hardship. Both were started by human activities. Lightning has been ruled out as a cause for both fires. I tried to get an answer from the Alberta government on the cost of the Richardson River wildfire, but they would not tell me. So I guess the question here is, if humans caused these billions of dollars worth of damage and ecological damage on top, why were there no prosecutions? Would the prosecutions have exposed that the industry is causing extensive harm and costing the public billions of dollars? And would the insurance companies have sued the responsible parties? It's the government that chooses to prosecute, and they chose not to prosecute. Okay, finally, final section here, very quickly, regulatory capture and the meta-organization. Very quickly, how does information within an agency become disinformation? Well, if you look at the red colors here, those signify whistleblowers or troublemakers, as they like to be called from the bosses, is in red. And then, and that also means it stands for unfavorable information. We see as it's passed up from the lower levels up through the management levels that the troublemakers are typically hampered, or they're removed or fired, or they're starved of resources. So those people who are the whistleblowers are being filtered out of the system. The truth about what's happening is filtered, it's spun. If it can't be spun to be extremely favorable, it never actually makes it to the upper level, such that at the executive level, all the executives are learning about is favorable information, and the people who are working with the executives are the enablers who have been promoted up through the organization because they support that organization. As a result of that sort of systemic information distortion, everyone gets a distorted view of reality, and then we are unable to correct our mistakes. That leads to disasters such as the Chernobyl nuclear disaster, the Space Shuttle Challenger, and the management of the Alberta Energy Regulator. If we look at the sort of the meta-organization that's responsible for the what we're seeing across the world, the center of the organization is the regulators, the producers, and the producers' partners. They're exchanging information and money all the time, mutually supporting one another. And then around that information firewall, you see favorable governments, political parties, legitimators, banks and asset managers, and various kinds of enablers that are sort of working together in the meta network to support the overall goal of control, their great political control and financial power. The weakness of this system here, and it does have a weakness, is this one. If we go to the next page here, we're digging into far more detail than we need here, but you can see the bottom, this whole foundation is based on the banks and the asset managers and the insurance companies. If the foundation is weakened by divestment and the refusal of insurance companies to insure this industry, then it will fall apart. There were 503 fossil fuel meta-organization lobbyists at COP26 inside the national delegations. They were working very quietly and effectively because they know that the survival of this industry depends on undermining climate action. Today, our federal government in Canada still provides $17 billion in annual subsidies to the fossil fuel industry. And although they've made some wonderful promises in terms of reductions in emissions, those are just promises, whereas the investments and the subsidies are real. So quickly here, the long trail that I took starting 6 years ago, following the breadcrumbs. I won't go through them again, but you can see how I started out long ago to notice something very funny, a little sort of red flag in a data set about spill recovery. That led me to ask larger and larger questions and to dig deeper and deeper till I finally had to realize that this was all due to the sort of the data corruption and the failure to manage this industry were all the result of a pervasive undermining of our democratic institutions by the fossil fuel meta organization. So right now in Alberta, we're faced with $260 billion cleanup liability. So we have both financial and ecological liabilities. We have captured regulators and captured governments, which undermine our capacity as a society to respond to the threats that we're facing on a day-to-day basis. We either have to make the successful energy transition globally, or we risk collapse of advanced civilization. I'd like to end with the words of Martin Luther King, where he noted that in time of crisis, it's not the glaring noisiness of the bad people that is so tragic, but the appalling silence of the good people. You are needed. Your voice is important. I'd like to acknowledge all the many people and organizations who helped me very quickly. The Gavia Group Incorporated, Laura Jackson and Patrick Lamb, Bob Cameron, Cecile Fausack and Bruce Jackson, Evelyn and Harvey Scott, the Keepers of the Water, and the Federation for the Humanities and Social Sciences. They allowed the publication of Hidden Scourge with McGill Queen University Press by their generosity. And finally, many people and organizations helped to provide information, data sets, reviews, anonymous reviews and otherwise, testimony, observations. And I leave this slide up here so you can all read the names of those people, and I'll end there because I'm out of time. Thank you.